In this video, I will be teaching the most advanced method for the Skewb, the series advanced method. This method only has two steps, the first one being to solve a layer, which would look something like this. And then the next step is to solve the rest of the puzzle. So with it only being 2 steps long, it's a pretty fast method. You can usually get around 2 to 3 seconds with this method. Now this is a very advanced method, having around 100 algorithms, so if you don't think you're quite there yet, there'll be some links in the description for some more intermediate and beginner methods to solving the Skewb. Now because there's so many algorithms and so much to learn, I'm going to be using a very simplified notation. So that means rather than having like R, U, L moves, since every algorithm is just solved with sledges, hedges, and U-Perms, those are the only letters that we use. So S means a sledgehammer, H means a hedge slammer, and a U-Perm is just a U. Now I use a rotationless U-Perm. It's about as fast as the normal U-Perm, but I find it's better because you don't have to do a Y2 at the end of some of the algorithms. The only other notation you have to know is how Y rotations work. Pretty much Y prime is putting the front face on the bottom, and Y is putting the front face on the top. The first set of algorithms I'll be teaching are the ones where all the corners are solved. I won't be going over the normal cases that you can get for like series intermediate because you should already know those. So there's the Z permutation, should look something like this. There's the H perm, which a lot of people do differently. I do it like this. But as long as you have an algorithm that solves it rather than doing like 3 sledgehammers, then you should be fine. There's obviously the U perm, which can be done from this angle. And if you use the rotationless U perm, also from this angle. And I find that's also quite helpful in these algorithms. Then there's also this case from the intermediate method, which is just 3 sledgehammers. And there's also a pseudo version of that case, where you have 2 adjacent and 2 adjacent, where you just move it like this. So you've got the case from earlier, do the 3 sledgehammers, and then undo that first move. Then there's also a 3 cycle like this, where you have 3 that are adjacent and 3 that are solved. This you should also know from the intermediate method, so I'm going to very briefly go over this. Where, well, the way I would do it for this case is I see we have yellow here and the yellow corners here. So I would put them opposite to each other. So now we've kind of just got a U-Perm where this goes to the back, this goes here, this goes here. And you would do a U-Perm. And then you would undo that first move. So that's pretty much every 3 cycle and 4 cycle, but what they don't teach you in series intermediate is the 5 cycles, which I'll go over now. So when you have 2 opposite centers, you want to solve them like one of them is a U-Perm. It doesn't matter which one, so for example I could do this one. And that leaves me with a U-Perm. Or I could do this one, which leaves me a U-Perm from a slightly better angle. So the way that I would recognize this would be this one, this U-Perm here with this center, and this center. This one has the top center. So I would do this one second, because I know that doing this one kind of preserves that. There is also the case where you have 1 opposite center, and what I would do here is I would solve the top center first, kind of like the beginner's method. So you put it in the back, do a sledgehammer, and it leaves you with a U-Perm. So one more time, I have this center which goes on the top, I put it on the back, U-Perm, right into U-Perm. For the case where there are no opposite centers, there's just one, your bottom color solved, I would look for the top center, put it on the front like this. So this goes to the top, and I would look to see where the top goes. It'll either go to the left, which in this case it doesn't, or it goes to the right, which in this case it does. We'll then go to that center, so this one now comes to the bottom, and keep in mind that this one's up here. So the way that I think about this is I do sledge, I go up to that center, sledge, go down, hedge, go back up, hedge. So that sounds like a bit of a long algorithm, but it's pretty easy to remember because it's just 2 sledgehammers and 2 hedge slammers with interchanging Y moves. So I'll go through it again. Sledge, sledge, hedge, hedge. And then for the other case, where this goes to the top and the top one goes to the left, I then start on the left and I do the same thing I did before, the same kind of thinking. So I do a sledge, sledge, then hedge, hedge with alternating Y moves, but this time we go down to the center that goes to the top. So sledge, sledge, hedge, hedge. The next set of cases I'll be going over are the Pie cases, named after the 3x3 case where you have headlights here and 2 facing away from each other here. Now this is a much bigger set than when all the corners are solved, so I'll be kind of breaking this down into where the top center is. And all my examples will be on white, so the top center is the yellow center. The easiest set to learn is where the top center is either on the right or the left, so I'll be teaching this first. The easiest algorithm is where you have two opposite centers, one on the front and one on the back, and then you have this one here solved. This case can be solved by using a hedge slammer from this angle, or if it's from this angle, where these two are opposite, this one's solved, you use a sledgehammer. The opposite case to that is where these two are solved, and this one is opposite. This one's famously known as the H-perm skip, where if you did a hedge slammer here, you would get an H-perm, which is pretty bad. But you can skip doing an H-perm if you start from the opposite angle, do a hedge slammer, so opposite of what you would normally do if the headlights were on the bottom, into a sledgehammer. So again, you'd start from here, do a hedge slammer, Y2, sledgehammer. There's also the opposite of that case, where you'd start from this angle, and the top centers here, do a sledgehammer, into a hedge slammer. The next case is where you have the top is either solved, or the top is opposite, and the rest of the colors are all adjacent. So this algorithm, if you use series intermediate, do a sledgehammer, gives you a Z-perm, which is pretty bad. And the difference between this case and this case, where the top is solved and the top is opposite, is you do a sledge and the Z-perm is kind of the back center and this one. Or it is the other one where it's here and then down here. So if the top is solved, you start from the back, do the opposite of what you would do for this case. This is a sledge, so I do a hedge from here, hedge, go down to the center, hedge, go back up and do a sledgehammer, go back down to do a final hedge slammer. So alternatively, if the top is opposite, you start from the front this time, do a hedge slammer, because again that's opposite to what you would do here, go up to there, do a hedge slammer, come down, sledgehammer, go up, hedge slammer. So it's kind of like you do two of the opposite of what you'd normally do, then one of the normal, and then back to the opposite. So there's 4 hedges and sledges in total. Then there's the other case, where you would solve it usually with a hedge slammer, and then they both give you a Z-perm. The rule still applies to if this center is opposite to these 2 corner stickers, then you start from the front, and this time you would solve this with a hedge slammer, so I'd start with sledgehammer, go down to it, do a sledgehammer, back up, hedge, down, sledge. And then when they're the same, I'd start from the back. This one's solved with a hedge, so I start with sledge, 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 hedge, sledge. And the reason why I said this is the easiest set and why I started with it is because everything else is just series intermediate. Just a hedge or a sledge into a U-perm. Because, I mean, that's pretty good to begin with. There are some tricks you probably should learn. Like, for example, looking at this one and seeing that this is an opposite, you know that this one's going to be solved. So the U-perm will either be from this angle or this angle. Or if you know from both angles, it doesn't really matter. You can just see instantly, you don't have to rotate or anything. But you can look from the back and see that this is opposite. So obviously this one will stay opposite. And it's U-perm from this angle. Another example would be if this is solved and this is solved. Obviously this doesn't change, this will be solved. And this solved one will go with the opposite side. So the U-perm will be here. The next set of cases I'll be going over is when the top center is on the top. For the case where all the centers around it are solved, you just do 2 sledgehammers. For the case where all the centers around it are an H-perm, you hold it from this angle, do a U-perm, and then straight into sledgehammer. So again, we have an H-perm, from this angle U-perm, and then you're just left with a sledgehammer. For the 2 cases where the outside are a Z-perm, there's the case where the front and the right side are 2 adjacent, and then when the front and the left side are 2 adjacent. For these 2 cases, there's not a series advanced algorithm to solve them, because they can't very efficiently be solved with just sledgehammers. There are algorithms out there that solve these 2 cases, and they are better than 2 sledges into Z, but they're almost more advanced than series advanced, so I would suggest to learn full series advanced first, and then learn these few cases that don't have series advanced algorithms. The next cases I'll be teaching are where there's a U-perm around the sides. So the way I think about it is there are 2 different kinds of U-perms. There's either a U-perm where the solved center is on the sides, so for example this is one with the solved center on the left, and this is another where the solved center is on the right. So for the cases where the solved center is on the left, for this one the opposite center is on the front, and for this one the opposite center is on the back, we hold it opposite to the opposite center, so I'll go over here, and since it's on the left, we do 3 sledgehammers. So sledge, going down to, we do 3 sledgehammers going down to the solved center, like this. Sledgehammer, sledgehammer, sledgehammer. And I'll do the same with this. Since it's on the left, we're going to do 3 sledgehammers, and we're opposite the opposite center. So sledgehammer, then we go up, sledgehammer, sledgehammer. Now for the opposite cases, with the solved center is on the right side here, and then this one, the opposites are on the front, and for this one, the opposites are on the back. We hold it opposite to the opposite center, so from the back. But this time, since these are on the right side, we're going to do a sledgehammer, go up again, do a hedge slammer, go up again, and then a sledgehammer. Same thing for this case. We hold it opposite the opposite center, sledge, go down, hedge, go down, sledge. So to go over all the cases again, when you have the solved piece on the left and the opposite on the front, you hold it from this angle because we're opposite the opposite. And since it's on the left, we do 3 sledges. Sledge, sledge, sledge. Then we have the other case where the solved piece is on the left. So again, it's 3 sledges, but we go up to this one now. And we start from the front. So sledge, sledge, sledge. Then we have the cases with the solved pieces on the right. So we do hedge in the middle. So sledge, hedge, sledge. And then when the solved piece is on the right and the opposite center is on the front, we hold it opposite the opposite, and we do sledge, hedge, sledge. Most of the cases where you have the top center on the back and the top center on the front are just mirrors of each other. So I will be teaching these two at the same time. So on the front, this one's opposite, and on the right, this one's opposite. And for this one, the front is opposite and the left is opposite. So the way you would imagine these two cases is you will hold one of the opposite centers on the back. So for this one, we have on the front and on the back here, and we just solve the OLL. And then for this case, where we also have 2 opposite centers, one on the front and now one on the right, we hold it from the other angle where we don't have an opposite on the front, do a sledge, and then we go down to do this through sledge. Then we have the alternate cases where we have the solved center on the front, and then again we have 2 opposite centers, and then 2 opposite centers. This one we have the opposite center over here, and this one we have it on the opposite side. So these are done exactly the same. You hold it so that there's no opposite center on the front, and you just solve the OLL, and you got the 3 sledge case. And then for the other case, we have opposite here and here. We hold it from this angle, sledgehammer, into triple sledge. For these two cases, we have solved left and right on both of these. But the difference is this one has the solved center on the back, and this one has the solved center on the front. You can imagine this like a U-Perm into this case. So this one's obviously solved with 2 sledgehammers, and these ones are just a U-Perm away from that case. So this one we have the opposite center here, we do a U-Perm, and then we've just got this case. And then here, the opposite center is not here, it's back here. So we do a U-Perm, and then this case. So these two cases were originally known as really bad cases, and there were no algorithms for it. But I actually created my own algorithms for these. They're pretty bad, they're quite a few moves, but they can be done pretty fast. So for the way that I recognize these cases, is we have, here the front is solved, because we have the top center on the back. And here the back is solved because we have the top center on the front. And we kind of have these two need to swap, and these two need to swap. And then here it's the same thing where these two need to swap and these two need to swap. So these two will be opposite, always on these two sides, and then these two adjacent. The way that I think about this algorithm is it is only a 3 sledge away from this algorithm. So you can see here, if we compare these two, the only difference between these two is this center is down here, and these two are opposite. And see these two are solved. So you would just imagine it as the 3 sledge case, like this. 1, 2, 3 sledgehammers into this case, which is 2 sledgehammers. Now it's not a very fast algorithm, being 5 sledgehammers long, but since there's only 1 rotation, it's not too bad. So again, with these two need to swap and these two need to swap into just a 2 sledge. You hold it from this angle, and you can already predict where the 2 sledge is going to be because it doesn't affect the corners. So I know that I'll have to rotate down here like this. So I'll do it slowly. We have 1, 2, 3, rotate down into 1, 2. And then done quickly, it looks like this. So now we have the case where we have 2 solved centers. So this one has one solved on the front and one on the left. And this one has a solved center on the front and on the right. So this case is the same where you have 2 opposite centers, where you would hold it like this and do, for this case, it's a hedge slammer to solve OLL. But this time you're going to go into a U-Perm. So again, the way that you can predict this is this one's solved. So when you do the hedge slammer, it'll be over this side. And obviously red is opposite orange. So we do a hedge slammer into a U-Perm. And then for this case, we hold it on the other side. And then since this one's the solved one, it's going to go to the back, which is opposite. And we do sledgehammer into U-Perm. So for the alternative cases, where we have the top center on the front, this one we have the solved center on the left and on the back, and this one we have the solved center on the right and on the back. So for this one, we'll do it from this angle, do a sledgehammer to solve the OLL, and we'll see that this one's solved, so it's going to be over here for the U-Perm. So sledge into U-Perm. And for the opposite case, we hold it here to do a hedge slammer, and since this one's the solved one, it'll go over here for the U-Perm. So hedge into U-Perm. Now keep in mind, if you do know the opposite of a U-Perm, you can do that as well. So here we see this one's going to go over here for the U-Perm, but we can rotate down and do a back sledgehammer into a normal sledgehammer. Some people do, it's kind of your own preference. I prefer to keep it consistent by always doing the same U-Perm. So for these cases, the way I'd recognize this, not looking at the top because that can get a bit confusing, but we're just looking at this one solved center. And these two are adjacent and this one doesn't really matter. So for this case, where the left side is solved and the top center is on the back, we do sledge and then up to the solved center, sledge, and then back down to do hedge. Alternatively, if you have the same solved center on the left but the top center is on the front, you do a sledge, go down, sledge, and then come back up for a hedge. There is also the opposite of those cases, where we have the solved center is on the right. So for this, we have the top center is on the back, so we go from the front, and we do sledge, and then down to the solved center to do hedge into hedge. So if the solved center is on the left, you do 2 sledges and then a hedge, and if the solved center is on the right, you do 1 sledge into 2 hedges. So again, if the solved center is on the right, we do 1 sledge into 2 hedges. So we go up and then back down. These cases are a little bit confusing, so I will be teaching these just the ones on the back and then just the ones on the front. So for these cases, you recognize it with one opposite center. So for this case, where the opposite center is on the left and the top center is on the back, we actually hold it with the top center facing us. And we start with a hedge, and we do a Y2 into a sledge, and then hedge to finish it off. So the way that I remember this is, since it's on the right and from this angle we have to go down to do it, we do our hedge, go up here, do a sledge, and then since when we started the opposite center was below us, we go down to do hedge and then down to do hedge. So one more time, when the top center is on the back and this from the front angle is on the left, we hold it like this, hedge, Y2, sledge, and then since the opposite center was down here, hedge. Then we have the other case where the opposite center is on the right, so we hold it with the top center facing us. This time, everything's inverted. So we go up at the end because the opposite center is here, and we start with a sledge. So we go sledge, Y2, hedge, and then since the top center was above us, we go here and we go sledge. One more time, we have the top center is on the back, and from this angle, this is on the right. We start with a sledge, Y2, hedge, and then go up because the opposite center was up, sledge. Now we have the other case where the top center is on the front, and here we have the opposite center on the right, and we have the opposite center on the left. So we have the opposite center on the right side and the top center on the front. Again, we hold it with that top center on the front, and since it's on the right, we do a sledgehammer, do a Y2, hedge slammer, and now the opposite center was below us before, so we do sledge. So again, we hold it like this, sledge, Y2, hedge, and then down, sledge. Then the alternate, where we have the opposite center on the left, we do hedge, Y2, sledge, and then since the opposite was above us, hedge. One more time, we have the top center on the front, opposite center on the left, hedge, Y2, sledge, and then hedge. The next case, the way I recognize it is that there's literally nothing to recognize it. We have just nothing, they're all adjacent to each other. And the way I differentiate these two is that we kind of have this corner matching with this center and this one with this one. And then here we have the opposite side where this one's matching and this one's matching. So the way that you would do this is you would hold it opposite to kind of like where these two, almost like a line is. So you'd hold it here, and you would do the opposite way you would solve this OLL. So you'd start with a hedge slammer and do 3 of them alternating. So hedge slammer, down, hedge slammer, up, hedge slammer, and then still alternating, you do a sledgehammer. So again, starting from this side, do the opposite way you'd solve the OLL, and then just alternate 2 more times, and back down to sledgehammer. This case is exactly the same, so I'd recognize that these two and these two. Hold it from this angle. The way you would solve this OLL is with a hedge slammer, so I'd do a sledgehammer, and then I'd start by going up to this yellow. So sledge, 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 and then end with a hedge. We do a sledgehammer 3 times, 1, 2, 3, and end with a hedge slammer. Then we have the alternate of that case, where we have literally nothing to recognize, every center is adjacent, but we do have these 2 lines and they're on the same corner this time. And here we just see that corner's the left corner and this one's the right corner. So the way that you would do this is exactly the same, except you would do it on the corner that has those 2 bars. So the opposite way to solve this OLL is a sledgehammer. So I'd start with a sledgehammer and go down to the top center. So 1, 2, 3, and then end with a hedge slammer. One more time, we have the 2 bars here. We do a sledge, 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 hedge. This one's exactly the same, except we start from here, then we do a hedge, up to here, do a hedge, hedge, and then sledge. So that is every pie case and corners solved case. Hopefully this was helpful. I'll leave a link to Sarah's original document in the description, and if you've got any questions, feel free to comment. If I've already uploaded the second half to this video, it should be right here somewhere. And this side is something YouTube recommends, so don't blame me if it's a weird video.